And it's been a very interesting run. A lot of things have changed. Our world used to be a lot simpler, right? Back when I started, it wasn't even HFC. It was just the C. Right? And we talked about products. We had trunk stations. I talked to my engineers today. They don't even know what a trunk station is anymore. So a lot of things have changed. A lot of architectures have changed. We have a lot of options in front of us. And with the number of options that are in front of us and the number of choices and the situation that our networks are in today, it's impossible. People ask me, well, what should I do? It's impossible to say what you should do. I'm an old sci-fi movie fanatic, and one of the old crazy cult movies was Buckaroo Banzai and the Sixth Dimension. And you remember that movie? John Lithgow, and it goes back to kind of the War of the Worlds, and the Martians came and how the cover-up, they really invaded, but this was the cover-up. And one of the famous sayings that I remember out of that, I don't know that it was a famous saying, but one of the sayings was, no matter where you go, there you are. And that's kind of like the way we are today with our industry. You know, you can pick any path. But it's important, I think, for us to have a plan. And I always talk to people when they ask me and say, where should I be going? It's important to talk about where you are today and where we're starting and where you want to end up. And there are a lot of places that we start from and a lot of different places that people want to go. And we talk about the trends, and you've seen some of the trends. And Garrett talked about some of the trends and how the bandwidths and the capacities have changed over the years. The capacity of the network doubles pretty much every other year. And we've had a pretty strong trend. We've had to keep up with this over the years. So we need to think about what's involved with our network and how long it's going to take us to evolve the networks, where we are today, whether we've got to do fiber, whether it's a simple upgrade, whether it's a more complicated upgrade to get through that, what we can afford, and a lot of different things. We talk about some of the things that drive this. You know, it used to be that it was very simple for us when you needed more capacity. You went in and you changed all your amplifiers out, and you got more capacity by adding more bandwidth. Then we got smarter about this, and as you put bandwidth in, we got new compression algorithms, right, that allowed us to make better use of the bandwidth. And then we just ran out of, that technology finally got to a point where you needed more bandwidth than we could support, so we put more bandwidth into the network. And we hope that technologies allowed us to make better use of the bandwidth that was in there. So we go through different cycles. You add capacity, you optimize the capacity, you add capacity, you optimize the capacity. So where are we today? We've got a lot of bandwidth in the downstream. The upstream tends to be our biggest challenge today. There are a lot of interesting things. I got a new doorbell, right? Simple little thing. New doorbell about a month ago. So now my watch buzzes every time somebody rings the doorbell at home. And I'm going, well, it could be just a bird flying by the doorbell. Or somebody rings the bell and I can get my phone out and I can see who's at the door. And we were recently on holiday and the alarms are going off and the police are at the door and I'm talking to police from the other side of the country. Well, all that's happening over our networks. That puts additional strain on our networks today. And beyond that, there's a little community associated with the doorbells, and I'm getting notices from other people in the town about what's going on in their neighborhoods that all puts strain on our networks. And how do we manage all that today? So those are the kinds of things that strain the upstream. The downstream, I keep saying, well, I said probably 30 years ago when we were going to 600, 750 megahertz, this will be the last one, we'll be done. It wasn't the last time I was wrong. So the next big, I think, capacity push is going to be the virtual reality. We've got a lot of different things, and we talk about how different compression algorithms help us with more SD programs or HD or UHD or super UHD. But when you get into the virtual reality and the 360 views that Nigel was talking about, that starts putting, it's another order of magnitude of capacity. And how do we deal with that in our networks? When's the right time to put that capacity into the network? Because today it's very expensive. If we're going to put 10 gigabits to everybody's home, we're not going to be able to afford to do that. It's not in a practical sense anyway. So we got to think about where we are today, where our networks are going to be, what we need to support today, and what we need to be able to support in 5 years, 10 years, 15 years, beyond that. What do we want to put in place? A lot of different ways to get there. A lot of different ways to get there. Is the capacity symmetric or asymmetric? Is it scalable? Are we trying to run out the scale options that we've got in our existing network, or have we finally gotten to the point where we're saying this just isn't going to scale anymore? In the US, Verizon got to that point 10 years ago. He said, my copper network, it won't support what I need to support anymore. And they put their big push in, I'm going to do fiber to the home. It got them a long way. But it was a massive investment over a lot of years. We've taken a look in the US, for example, and said, if I wanted to go fiber to the home across the US, all the way to the home, the amount of time it would take to do that, if I did it at the speed Verizon did it, and Verizon, very aggressive with their build-out, our math came back and said 38 years. I said, okay, no problem. I get to retire. I don't have to worry about it. But in the practical sense, right, we've got to do something between now and then. So it's, where are you today? What do you have the appetite to do as you go forward? You've got to take a look at the reliability of your plant. If you're going to wait, if you're going to take you 38 years to do an upgrade, or even if it's going to take you 5 years to do an upgrade, does your existing plant last through that next 5 years? The last big push, right? The last big push was the end of the 90s, right into the early 2000s. Equipment hasn't been touched very much since then. We had a lot of different technology options available to us that allowed us to take advantage of the network. Different DOCSIS, levels of DOCSIS, different compression algorithms allowed us to do a lot of different things with the existing networks. We didn't touch the amplifiers. It was kind of sad for me because I grew up in the amplifier world in a factory that made lots of amplifiers. And for the last 5 years, our amplifier business was kind of flat. Everybody said, well, I'm trying to think of how many years ago they started saying amplifiers were dead. This year I'll make more amplifiers than I have in any of the last 10 years. And I'll probably make almost 50% more amplifiers because those networks have finally gotten to the point where something needs to be done. And the operators, to a very significant extent, don't want to invest in amplifiers anymore, but there's no choice. A big part of this is just maintenance. Millions and millions of amplifiers out there that we've got to do something with to hold us over till the next wave. So the missing component up here is time, right? The timing also drives a lot of our choices. So the decades of exponential growth have been a big deal. This is a scary laser pointer. We've always talked about kind of the distinction between the downstream being, a lot more capacity in the downstream than in the upstream. Get to this point here, we're kind of where we are today, where we talk about this step function. where we now talk about symmetric services, and they now match up. And how do we do that transition? How do you operate, how do you transition a network from a traditional kind of subscriber split where it's 40 or 60 or 80 megahertz in the upstream to something that's 200 megahertz? How, just logistically, how do you do that in your network? So there are challenges with that. And then what's the right amount of capacity? Garrett, I think, pointed to this with the virtual segmentation. Very interesting discussion. And how do you take an existing service group and improve the performance within that service group and spread the capacity that DOCSIS gives you? I mean, DOCSIS is a tremendous tool, right? Really designed for point-to-multipoint delivery, really optimize the bandwidth. What's the best way to do this? So we talk about we've simplified a very complex formula that says, you got to talk about the number of subscribers in the service group and the average consumption of the subscribers in the service group, right? That's one of the blocks that you need to be able to deliver. And then you have to be able to deal with what our marketing colleagues typically have dealt with, and it's like, mine's bigger and faster and better than everybody else's. So what's that billboard data rate that we've promised? And that billboard data rate grows pretty substantially year over year, and that's the competitive threat. So you have to be able to deal with that maximum rate, the T-max, as well as the T-average. And there's some very interesting things that start to happen, when we try and figure out what the right choice is for maximum data rates and the best quality of experience that we're looking for. So we've got a simple formula here that allows us to do some other analysis to try and say what's the right service group and talk about what the right size service groups are. So this was a very interesting set of charts for me. We talk about this the first block over here where we go back a few years and talk about 500 subs in a service group where the average data rate's 600 kilobits, right? And the max, right? The billboard data rates were 200. You didn't need a lot of capacity in your network in relative terms. You talk about where we think we're going to be in another 5 or 7 years, right? Same size service group, 500 subs. You take a look at the Nielsen curves, and the average data rates are now up at 35 meg. And the max, that billboard rate's going to be above 10 gig. Or even if it's just a 10 gig, it doesn't make an awful lot of difference. So the gray block here talks about what you need to be able to support for that T-max. And if this was 10, this just comes down about a gig. And this is what happens it's a static capacity. That's kind of your broadcast and the average data rate. So this is what's going on in your network, and this is when somebody goes and is pinging the network to see, oh, look how fast I am. Or they're doing a big file download. They need to be able to support this. And it's very interesting now, you're now up to 31 gigabits of capacity. It's a lot of capacity in the network. How do you put that in? The interesting thing that happens, though, is you go down to, you divide your service group up from 500 down to 100. You still need that same peak data rate. So you still need this big, huge gray chunk to support that. Your static capacity drops down because you've got fewer customers. But by dividing the service group from 500 down to 100, so you've got 20% of the number of customers, you haven't cut the amount of capacity in your network even in half. So we talked to the MSOs a lot about, they're saying, well, I want to get smaller and smaller service groups. I said, you really need to be careful about this. Because smaller service groups, when you were at 10,000, was the right thing to do. When you get down to 500, 250, and our number would be, say you want to be about between 200 and 250 homes passed, with a penetration rate in the 50 to 60%, so you're in 100 to maybe 125 actual connections in that service group is probably the optimum number of connections for a service group that allows you to take advantage of the DOCSIS capabilities in that point to multipoint, and also allows you to give the best quality of experience to your customers. And on the financial side of the house is probably the optimal use of cash. So figure out what the right service group is, what you want to be able to deliver, what you're looking at on the calendar, what the timeline is for your network upgrades. We talk a lot about amplifiers. We've gone from cascades in ancient times now that were 40 and 60 or more amplifiers deep. Remember those cascades? Now to 6 amplifiers and node plus 0. This is an interesting chart, and there's a lot of detail in this chart. But the interesting part of this to me was this is the performance we talk about, the type of performance you can get data rate throughputs at a particular point. This is node plus 0. I'm sorry, yeah, this is the node plus, if I got this right, node plus 0 is up here. And this is a node plus 6. 44 wavelengths, this is distributed access, so this gives you, if you still go a remote PHY kind of architecture with amplifiers after that, this would be no amplifiers, this would be 6 amplifiers. You got pretty high performance. You're still up here, you're doing 4K kind of performance. In our traditional architectures, you know, whether you've got 6 amplifiers or 0 amplifiers, the amplifiers aren't the limiting function from a performance standpoint. It tends to be, this is an indication of your optical links and the type of optical links that you've got in your network are really the limitation. It's not the amplifiers. So the push today is, that we see is more to, how do I position my networks with their optics to be able to give me the right characteristics for the future, versus how do I get all my amplifiers out today? Because this says I've got time to take the amplifiers out of the network. It's how do I get my fiber infrastructure positioned for what I need to do, because that's the important piece. And fiber to the home today isn't necessarily the right step. Fiber to the home, like when you've got the kids in the car, it is a journey. And it's how long is that journey going to take, and it's what's the right time for you to get fiber to the home, and what's the right expenditure. And when you take a look at the technology curves and the costs associated with the different technologies, how does that migration take place, and how do the curves adjust so that you're making the investments in the network at a time that's appropriate to be able to support the needs and the drivers in that network. And then finally, aging plant. We did a study a few years ago where we took a look at some of the statistics associated with amplifier failures. And some interesting things, you can summarize everything here. Through the first 10 years, it doesn't really make any difference. Since we've seen a lot of different amplifiers, typically 4 or 5% cumulative failure rate through the first decade as the amplifiers are deployed. Things change, though, when you cross through that 10 years. By the time you're out to 15 years, you're not failing at 0.5% a year on average. You're failing at about 5% a year on average. And you're changing, the failure rate is changing at about 1% a year. I say I go from 5% to 6%, that's right, doesn't sound like a lot, but when you think, if you're the operations guy and I'm going, well, I've got, 100,000 amplifiers in the system, I've got 5%, okay, I've got 5,000 amplifiers I got to service this year. Next year it's gone up 1%, so instead of 5,000, I've got 6,000. I've got 1,000 more amplifiers that something's going wrong with in the system. And the year after that, it's, over 7,000 amplifiers. And I got my boss coming and talking to me and saying, I've got to reduce the OpEx going on in the network. Meanwhile, my amplifiers, I'm losing 20% more amplifiers every year. That's why they're putting new amplifiers into the networks today. You get out to 20 years where we're getting to on a lot of these, and it starts getting pretty scary. We're dealing with an operator today who's out in this range, who just announced a crash program that's going to go back in and change out just over 100,000 amplifiers in a year. Yeah. So, have a plan. That's the message on this one. And then with architectures, there are a lot of choices. There are more choices than we could talk about and get into if we spent, the rest of the week here. So I'm going to talk about just a couple of different things. Fiber deep, node plus zero has been kind of the architecture of choice for a lot of years. Very simple architecture. It gets fiber to within about 2,500 feet of the subscriber. It helps reduce power and maintenance. If you've got the opportunity to do it, it gets the old amplifiers out of the system, gets node positioned. It's DOCSIS based, so you get to take advantage of that point to multi-point statistical muxing in your network, and it positions you for a lot of the future architectures. One of the challenges and one of the arguments that we use a lot of times to choose a different architecture than the traditional node plus zero in an upgrade is that when you actually go in and do the designs and look what's involved in upgrading from a classic HFC design to node plus zero, how many of you would be surprised to know that you put in almost the same amount of new coax as new fiber when you do node plus zero? That's the reality. When you do node plus zero, almost as much new coax goes in. Because those new nodes, if you optimize the design, aren't where the old amplifiers are. So a lot of the coax needs to be rerouted. And fundamentally, there just seems to be something wrong with putting in as much coax as fiber when you're doing node plus zero. So we've argued about some different things. And Garrett's got to give an excellent opportunity there. You don't have to put in all that fiber. So there's some different ways to go and approach node plus zero where you're aggregating the remote PHY. And there's some different architectures that allow you to do some very similar things. So you've got options with node plus zero. RFOG got defined back 1990, almost 20 years ago. We were transitioning from DOCSIS 1.0 to DOCSIS 2.0. It was the cable industry's answer to PON. It was our fiber to the home architecture. It was a great option. It got fiber to the subscribers. It was still DOCSIS based, so our back office solutions were maintained. All the CPE was maintained. We could do mixed mode with HFC and RFOG. It made it pretty simple to operate the systems. RFOG solutions today allow you to get more than 2.5 gigahertz in the downstream and more than 500 megahertz in the upstream. So you're talking about 20 gigabits down, 5 gigabits up. Are technically possible in there. It ends up being a great bridge to PON. Architecturally, you'll see that they look the same. Power and maintenance go way down. The challenge, though, is you've got to get fiber all the way to the home. And there's a lot of time and money associated with that. You still may have to support powering a lot of other elements in the network. One of the big challenges in the U.S. where they've deployed a lot of metro Wi-Fi is that all those access points are powered off the cable network. So if they go in and they run fiber every place, they still can't de-energize the coax because all the Wi-Fi access points operate off the coax. So they still end up maintaining the two networks. And it can be pretty complicated to support the number of service groups and from a head-end standpoint, just the optics going in both directions to be able to support that. But the challenge with R5 is we move to 3.0. Everybody's familiar, I think, probably with OBI and the challenges that presented and the problems. There are a lot of different ways now to manage OBI. We put some active elements back out into the network is one of the ways that I often promote. Since your networks are still powered, it allows you to prevent OBI from occurring to begin with. It allows you to take advantage of the bandwidths and the capacities. And when you're going to the PON architectures, we found that the architectures, right, if we go back and forth here, not an awful lot changes architecturally. And where we get out to the optical splitter in the field, because with PON, you also want to have larger service group size. Used to be, we were all trying to get the 64 homes passed. Not very efficient way to do it. So we put a remote OLT out into the field, so we still need the powering out there. It's a good way for us to support that, but it now gives you the symmetrical bandwidth that you may have been looking for. It's Ethernet based. The CPE gets to be less expensive. If you're migrating your network, though, you've got the challenge of potentially operating two back office systems, and again, the coexistence of the two networks as you migrate from one to the other. But this is a good path in a lot of cases for the operators. And then as we keep going after that, we get into a lot of remote, we tend to talk about remote gadgets because there are a lot of different options for here. Remote PHY, remote MAC-PHY, remote OLTs. You've now got fiber again within 2,500 feet of your subscribers. One of the big advantages of remote PHY is that it really allows you to conserve fiber resource. You can get 40, potentially 80 wavelengths on a piece of glass. So if you've got a network that's very fiber poor, you've got the ability to use that existing infrastructure to put a lot of capacity out to subscribers in your network. So it conserves fiber, it allows you to reduce fiber. You're still DOCSIS based. It reduces a lot of the head-end constraints for power, space power, heating and air conditioning that goes into those locations. It does put that resource out into the network, so you have to be able to provision that. But the other big opportunity that it provides you is the opportunity to get you positioned for full duplex, right? You can't have any amplifiers between the full duplex deployment and the home. So you need to be close enough so that you can get there with that full duplex. I won't talk about full duplex today because that's a whole other set of complexities that we're trying to work through. But when you do this, a lot of different ways to go from a traditional architecture with an integrated CCAP solution with an HFC deployment to eliminating the HFC and going to a remote PHY, fiber deep solution or remote MAC-PHY. A lot of different religious discussions go on about what's the right way to do this. A lot of those are based around, again, what you want to be able to do. A lot of potential challenges with latency with the remote PHY. So if you're exploring remote PHY versus remote MAC-PHY, talk to your engineers about latency if that's important to you. And then finally, right, another buckaroo banzai. If you don't know where you're going, any road will get you there. Think about where you want to be tomorrow. It's important. We're often distracted by, you know, the latest and greatest, the bright, shiny object out there. Is that where, you know, from a practical sense, from a business sense, is that where I want to be? And it might be where you want to be in 10 years. In a practical sense, is it a place that you can get to from where you are today? Is your network in a position where you still want to evolve what's going on in that network? You can still go through upgrades and a number of changes and migrations over the next few years? Or are you at a point where, you know, I'm going to overbuild it and rip everything out underneath it when I'm done? And then what do you really need to, right, again, focus on the performance that's really important to the networks. And Nigel talked about what's important from an encoding standpoint, right? We've got customers say, you know, well, my target's an MER of 39, for example. You know, if I can get 41, that's better. Well, does 41 let you get up to the next standard, or is it just you're paying more money to pay more money? As a manufacturer, we're always happy to take your money, but we want you to keep coming back. So we'll encourage you to kind of find the right balance. And that's really the end of my pitch today. It's what's the right balance, pay attention, get yourself a plan, and a good plan tends to get you where you need to be, regardless of the technology shifts. Over the last 40 years, although a lot of things have changed, a lot of things have stayed the same. And a good plan is still a good plan, and I encourage you to figure out what you need to do and stick with it. Thank you.
Are there any questions? Yes?
John, interesting stuff. I wonder if you might offer us your opinion on why you think that the drive towards symmetrical services, what's actually behind that? I really don't see much real evidence that it exists, but it appears to be a really hot topic.
Well, yeah. So I'm an engineer, so you're going to get an engineer's opinion on this one.
Good stuff.
I think it's the marketing guys. I don't think there's any good reason to be going to a symmetrical service. I think there are some good arguments to go to higher upstream, but you know, we talk about 10 gig down and 10 gig up. Even when you take a look at some of the things that you potentially want to be able to do with virtual reality gaming, it's hard to see what you would want to do with 10 gig up. But I'm also the same guy that said 750 was, you know, the farthest we're ever going to need to go. I see a lot of reasons to go to higher downstreams or provision for higher downstreams. We talk about being able to get to 10 gig out to a service group. That's what we can support today with remote PHY. I see that going to higher data rates. The question is, when do you want to go to the higher data rates, and more importantly, what the right service group size is. we argue a lot, or I argue a lot with customers who want to get down to, I want to get down to 32 homes. And they think I'm crazy because I'm trying to talk them out of service groups that are that small. I said, please don't spend this money. And in particular, the sales guys get a little crazy when they say, please don't spend this money. Because I think they start into a project and they find out that pretty quickly somebody's going to pull the plug on them because they're spending a lot of money, and the improvements that take place in the network, right, aren't noticeable by the subscribers. They can't, if you can't consume it, and more importantly, now I'll pick on my wife. She's always saying that she hates Comcast. I think there's a lot of people in the States that hate Comcast. She goes, the service here is so slow, I never can get my download. And I look at what she's doing, and I ping them, and I go, this isn't, I hate to defend Comcast, but this isn't a problem with Comcast. This is probably a problem at the far end of the pipe, and they can't pump the stuff into it fast enough. And so that quality of experience ends up being a very interesting thing. And you get to a point where, again, it's a balance between that whole ecosystem. And I think as network providers, it's incumbent on us to have the plumbing in place, so to speak, so that, and because of the amount of time it takes to put that in place, we need to get ahead. We talk about that our FOG with 2.5 gigabits down and 500 megabits up. And that was a few years ago. Probably in a practical sense, the bandwidth that we can support today is twice that, 5 gigabits down and 5 gigahertz down and a gigahertz up. Go out and talk to MSOs, and they go, well, what do I do with this? I don't have anything I can connect to the ends. I go, that's true. When we first started deploying a gig down, you didn't have anything you could connect to the ends either. How long is it going to take you to build out your network? And if it takes you 3 years or 5 years, you would hope that when you're done building your network, that you haven't gone far enough up the Nielsen curve that you're out of capacity again. I always argue, the highway projects, they're expanding the roads, and just about the time they're done, they need to start expanding the roads again. So it's a long answer to I don't know why people need symmetric.
Thank you very much.
Are there any more questions? Yes, one up there.
Thank you, John. In the UK, the civils is a ducted network underground. Do you see a different game plan from an aerial network for the deployment of new amplifiers, etc., etc.?
Well, some interesting things are different every place in the world. And underground, I think in Europe in particular, provides some unique challenges just because of the history. There are a lot of places in the world, including the U.S., where there's now a lot of underground. Some unique challenges to the underground in Europe. You're going to pull the cobblestones up one at a time and put them back down in exactly the same place they came out of. So there's been a lot of work, and I've worked with a company in the U.S. to can you extract the center conductor and the dielectric out of the existing coax?
Can I just say that the network in the UK was not directly buried. It is all ducted within 100 millimeter pipes, 4-inch. So to deploy fibre becomes much more interesting as long as the pipes aren't blocked up or the actual amount of space in them.
So let me do both parts of this, and I'll cover both the ducted and the direct buried. So I've seen customers that are now literally blowing the insides out of their hard line. And it's a very interesting process. When I said there's no way this is a practical way to do it, I've seen them take the insides out of 1,500 feet of coax in about a minute and a half. It's like somebody's got a big can of silly string with that process, and it just squirts out. It's pretty cool to watch. It doesn't work with, I forgot who it was talking about the disc, right? You can't do that with the disc. And some of the older European style cables, which were solid conductor and it was kind of a corrugated, doesn't work. You get into some of the ComScope or Times fiber, those kinds of fibers you can blow out. When you get into the ducts, we look at architectures that say, you know what, I can put fiber in parallel to the existing coax. And we've proposed to a number of customers to say, look, you take your existing nodes, and those nodes end up being aggregation points. And those aggregation points serve the amplifiers, and the amplifiers we can turn into smaller nodes. So if I can get fiber through the ducts out to where the amplifiers are, and I'll move fiber out, put a very simple node into the location. I can aggregate it back where I had a node. I can locate my remote PHY device there if that's what I want to do. I can do my segmentation back at that aggregation point if that's what I need to do. And at some point in the future, I need to move and do my segmentation deeper. You've got the ability to do that. So there's, the ducts give you a lot more options clearly than the direct buried does. So we've seen customers moving with that as well.
Thank you.
Any more questions? No? Okay. Is the UK in a similar situation to you described in the States in terms of age of amplifiers? I mean, I personally have no idea, and maybe you don't either.
Looking at Alan, I would say the answer is yes.
I think everybody upgraded to 600 and 750 pretty much simultaneously. It took off in the US and it took off here in the 90s. And I'm guessing that's kind of where they still are in general. So I think yes, the answer is in technology terms, amplifier technology, very similar.
Very similar.
Right, okay. So we've still got some thermionic valves out there, have we? EF86s and...
Well, I don't know, Chris might have put it through it.
Oh, I'm sure Chris has.
But I would suggest that probably the UK is much farther along with taking fiber to the home than the US is today. Much further along. Virgin is pushing hard on that one.